Welcome to today's explainer. We're going to explore the absolutely fascinating math behind 3D shapes and figure out how comparing their volumes can actually help us make way smarter choices in the real world. We're diving into the mathematical proportions of volumetric comparison. Now, I know that sounds super complex, but stick with me. I promise by the end of this, you'll look at the everyday objects around you in a totally different light.
So here's our roadmap for today. First, we'll tackle the volume puzzle. Next, we're unlocking the formulas. After that, we'll look at some real-world math applications, followed by a quick chance to test your knowledge. And finally, we'll wrap up with the source material's unique take on math, morality, and you.
All right, let's jump right into part one, the volume puzzle.
Okay, imagine two containers sitting on a table. They have the exact same footprint, the exact same radius, and they reach the exact same height. But one of them holds drastically less space inside. Why does that happen? Think of a standard soup can next to one of those classic cone-shaped paper water cups. If you try to fill them both up, their capacities are totally different. Now, your gut probably tells you the can holds more, right? But as focus learners, we want to know exactly how much more and what the real mathematical reason is behind it.
That brings us to part two, unlocking the formulas. You know, what's really fascinating here is that the mathematical formulas for these two shapes are almost identical. It's wild. For a cylinder, the volume is simply pi times the radius squared times the height. Simple, elegant, straight to the point. But for the cone, the formula is identical, pi times the radius squared times the height, except it has a tiny, game-changing fraction sitting right at the front, 1/3. Because the core building blocks are the exact same, the relationship between these two shapes is perfectly fixed.
So here is the absolute crucial takeaway. A cone will always, without fail, hold exactly 1/3 the volume of a cylinder that shares its exact dimensions. Literally always. It doesn't matter if we're talking about a microscopic thimble or a massive skyscraper-sized storage container. If the radius and height match, that cone is exactly 1/3 of the cylinder, period. Let's actually test this with some real numbers to see it in action. Say both shapes have a radius of 3 centimeters and a height of 9. For the cylinder, 3 squared is 9, times 9 gives us 81. So, 81 pi, which is roughly 254.5 cubic centimeters. Now, instead of doing all that heavy lifting again for the cone, we just apply our rule. What is 1/3 of 81 pi? Boom, exactly 27 pi. The math perfectly backs up the theory every single time.
Now, let's move on to part three, real-world math applications.
Okay, imagine you're the logistics manager for a huge manufacturing company. You have super limited space in your warehouse. Specifically, you've got a footprint with a 5-foot radius and a 12-foot ceiling limit. Your boss says to store as much water as possible. Knowing this mathematical rule makes your job a breeze. The cylindrical tank holds 300 pi, while a cone tank with the same dimensions holds just 100 pi.
The numbers do not lie, folks. The cylinder holds precisely 3 times more water. If you had picked the cone-shaped tank just because it, looked kind of cool, you'd be literally sacrificing 2/3 of your potential storage capacity. Understanding this simple volume comparison gives you the power to make incredibly practical, informed business decisions in a snap.
Or think about a baker working with measuring cups. If their cone-shaped cup holds 200 cubic centimeters, we instantly know that a cylinder-shaped cup of the exact same size holds 600. This is the absolute beauty of proportional math. You don't need a ruler, you don't need a calculator, you don't even need the actual measurements, because you know the relationship, you just work backward or forward. The cone is 200, just multiply by 3 to get the cylinder. It's rapid-fire reasoning.
So ultimately, when a company compares packaging efficiency to hold the absolute most liquid possible in a given space, the cylinder wins, hands down. If your cost is based purely on maximizing volume on a crowded store shelf, the cylinder provides exactly 3 times the value of a cone. Comparing volumes helps us crack a code on which objects are fundamentally more cost-effective.
All right, let's head into part 4, test your knowledge.
I actually want you to pause this explainer right now. Seriously, grab a pencil and try tackling these two problems to see if you can instantly spot that mathematical relationship. For the first one, if a cone is 100 cubic centimeters, what's the cylinder? Well, we just did this with the baker, it's 300. And for the second, if the cylinder is 240 pi, the cone is 1/3 of that, which is 80 pi. Whether you get the cone first or the cylinder first, you've now got the exact mental framework to instantly solve for the other.
Finally, let's look at part 5, math, morality, and you.
Now, the source material we're looking at today takes this whole concept completely beyond geometry, using it as a metaphor for life. It references the biblical scripture, "To whom much is given, much will be required." The curriculum suggests that just like we measure the physical capacity of those 3D shapes, we should also recognize our own personal capacity. The text argues that when you gain knowledge and education, your internal capacity actually expands, kind of like moving from a cone to a cylinder. And the framework posits that with that greater capacity comes a greater responsibility for how you use it.
The HeroesMart Academy Godly Learners series draws a really interesting direct parallel here. Their curriculum argues that combining education with biblical morality is absolutely vital. They posit that having a huge intellect without a moral compass can actually lead to harmful choices. They use the cylinder as a metaphor for this. Just as a massive cylinder can hold a ton of life-giving water, the source suggests it can also hold toxic waste if a person isn't careful about the values they're pouring into their newly expanded capacity. From this specific perspective, the text argues that intertwining morality with your education brings true peace of mind. The framework suggests that when your mathematical reasoning and your moral reasoning are totally aligned, having an expanded mental capacity doesn't lead to anxiety or destructive choices. Instead, according to the source, it leads to genuine peace. The source leaves us with a really provocative final thought to reflect on as we wrap up today's explainer. You now have the exact formulas to calculate the space inside a shape, and you know exactly how to compare a cone to a cylinder to find out which holds more. But when you look at your own life, your education, and your moral compass, according to this framework, are you maximizing what you've been given? Are you filling your capacity with choices that build up or tear down? Something to think about. Thanks so much for joining me for this explainer. Keep seeking those answers and keep on learning.